Okay, so we're going to be discussing now probabilities. In a previous video, we discussed what a probability density function was. But now what we're going to do is we're going to determine, using a probability density function, what the likelihood is of some event occurring. All right, so in this case, we're looking at some PDF called e to the negative x. And what we're going to do is we're going to integrate this, all right? We're going to integrate it over the given interval by utilizing a computer algebra system. And in this case, we're going to be utilizing Wolfram Alpha. So let's go ahead and first write out what the integral will look like, and then we'll take a look at Wolfram. All right, so I'm going to go, in this case, I have the function e to the minus x dx. Now, the probability that I'm looking for is the probability of a value of x being greater than 1. So we're going to, since this is continuous over 0 to infinity, we're going to actually take a look at 1 to infinity. All right. If there was some constraint, on the interval, it might say, the probability of a value being between 1 and 4 or something like that, then we would integrate in that case from 1 to 4. But this one just says greater than or equal to 1. So we're going to integrate then from 1 to infinity. All right, we're going to take a look at that. And then we're going to figure out what that probability is. So let's go ahead and take a look at what Wolfram Alpha has to say. Okay, so here is what Wolfram Alpha has to say. For e to the minus x integrating from 1 to infinity, we get roughly 1 over e, which is 0.36788. I'm going to say rounded off, 0.3679, 4 significant figures there. All right, so the likelihood of a value being greater than or equal to 1 is roughly a little over 36%. Okay, and that's what we would get there, and that's how we interpret this result. All right, let's go ahead and take a look at a couple more. So here's number 5. This function f of x is equal to 1 over 4 e to the minus x over 4. All right, and we're going to be looking at this function. We know that it happens to be continuous and non-negative from 0 to infinity. We're concerned with the probability of some value of x being between, let's say, 1 and 5. All right, so that's what we're looking for here. All right, so what we're going to do is we're going to integrate that. And in this case, we're going to integrate from 1 to 5 because that's where we're looking for the area under that part of the curve. All right, so let's see here. 1/4 e to the minus x over 4 dx. Let's go ahead and take a look and see what Wolfram Alpha has to say about this one. Okay, so as you can see here, you should be very careful with what you type. All right, notice my use of parenthesis when I'm typing. And then notice also that the output here matches my integrand there. All right, so what we're doing here is we're noticing that we get 0.49230. So the integral here, the answer that it evaluates to is 0.49223. So this means to say that values between 1 and 5 for this PDF, values of x between 1 and 5, the likelihood of that occurring is 49% of the time. So this is the probability of this event occurring. All right, let's go ahead and take a look at one last example. And here we're going to be utilizing a cosine function. And I know many of you love trigonometric functions, but the important thing to note here is that we're going to be utilizing, again, Wolfram Alpha to help us out. And so that actually makes this quite easy. So we're going to be looking at cosine from 0, let's say, to pi over 2, the closed interval. But we want to find the probability of a value of x occurring, let's say, between pi over 9 and, I don't know, pi over 4. All right, so we're going to take a look at that. So what does that integral look like, first of all? Well, it's for sure the integral of cosine of x dx. And then we're going to go from pi over 9 to pi over 4. All right, so that's what this one will look like. Okay, really not much to it. We plug this in to Wolfram Alpha and let's see what we get. Okay, so we see here we've typed it into Wolfram and look what we get, 0.36509. Of course, we're going to round, let's say, to 4 decimal places. 3651.3651 looks good to me. And that right there is what we would get. Again, we're utilizing a computer algebra system, in this case Wolfram Alpha, And it greatly helps us answer these questions because it simplifies a lot of the work that we have to do. We've spent a lot of time learning about various integration techniques. Now, let's see how, what we're doing here is we're building up so that we can learn how to apply what it is that, we've amassed, the knowledge we've amassed. So I hope this video was helpful. And remember, like and subscribe.